All right, can everybody hear me? Is this working? Is this good? Everybody hear me? Yes, no? All right, I'll have to do. A bit louder? Okay. Oh, man. It's not that kind of talk. Okay. So I'm talking today about hopping fences or practical WAF attacks. So first of all, hi, Winnipeg. About 10 years ago, I moved to the West Coast and not so much liking the weather here. Seems like every time I come out for BSides, I get nailed by a snowstorm, so it's all good. My name is Yvan Boily. As Ron said, I worked with the Manitoba government for a bit. I'm a former Securus alumni, one of the first, actually, if I recall correctly, and then have been in a bunch of different roles since then. I'm currently working for Fastly and working in the security research team. So if you saw Chris's talk yesterday, he and I work in the same team. And so one of the big things that we're working on at Fastly is building out WAF defenses that are baked into our edge security service offerings. And one of the fun things about web application firewalls is that they are capable of doing all kinds of really neat things, but like every other defensive technology, they have a bunch of different weaknesses. So I'm going to talk a little bit about some of the things that we kind of look for when we're implementing new WAF rules, and the other side of the quality control and security capabilities of what WAFs can do and how they can leave you exposed. So first off, some of the pros of running a WAF are that they can be relatively easy to configure. They're pretty cheap to deploy depending on what stack you're using. They're often baked right in. If you are doing any kind of e-commerce stuff, you get to tick off your checkbox for PCI compliance. You don't have to, I believe you still get to skip some of the other due diligence stuff if you have a web application firewall in place. And you can also use virtual patching as a stopgap measure. So if you have a vulnerable application, it becomes a lot easier to mitigate that in production if you can hack together a web application firewall rule to plug the hole. Some of the cons about them, as easy as they are to configure, they're just as easy to misconfigure. So you can imagine that if you spend a lot of time crafting virtual patch, but you miss a single character, all of that work goes out the window. You also have to balance false positives because nothing will make your production engineering team scream at you louder than filtering out all of the legit traffic from your website. It's inline infrastructure, which means that if you have any kind of failure in your WAF, it can interrupt the ability of your users to reach an application. They can also, if you have anything that's doing transformations on content as they pass through, you can introduce errors that users can't figure out what's going on. They also radically increase your attack surface. I'll talk a little bit more about why that is in a few minutes. And the other problem with virtual patching is it's really easy to deploy a virtual patch into production, but everybody here probably has a war story about deploying a proof of concept in production and then never being able to pull it right back out again when it's time to fix it. So when I'm doing red team work and I find out that there's a virtual patch in place, it makes me very happy because it means the vulnerabilities probably still exist in the application on the other side. So when we kind of step away from all of those different things and we start thinking about what we can do with them, Chris spent a bit of time yesterday telling you how you can test them. FTW is a project that provides the ability to really good and reliable quality assurance on new WAF rules, and it's not just applicable to our WAF product. Anything that uses the mod security rule set gains some of the benefit from that. You can see the commit history in the project has a bunch of different folks from Fastly, and both Fastly, current Fastly staff and Fastly alumni have contributed to and continue to contribute to the CRS project. But when we're looking at coming at it from the other side, if we're an attacker, there's one real guiding principle that makes our lives much easier if we're attacking it, and that's because Jon Postel put this really great concept into building RFCs. If you don't know who Jon Postel is, he's an internet superhero. You should learn about him. He's really cool. So the basic principle is be liberal in what you accept, be conservative in what you send. So what this means is that if you are a client, you want to make sure that you're sending as many well-formed requests as possible. But if you're a server, you want to process them as many different types of requests and make best effort to process as many requests as possible. On the converse, if your client is now receiving the communication instead, you want to make a best effort to parse that and process it and render it really as accurately as you can. And if you are a server, you want to make sure you're only sending content that's appropriate. Now, the other area that people are very familiar with this is in web security. If you have ever had to deal with the joys of doing web development for an older version of Internet Explorer or older web browsers and cross-browser compatibility, this quote is also your nightmare there. Now, this becomes a really important issue when you're dealing with web application firewalls, because browsers and servers are your friend if you're an attacker, because they do all kinds of things like content sniffing, so you can lie to a web server or a web browser about what kind of content you're sending, and oftentimes they will process that for you, say, oh, no, I know you said you wanted to send me a zip file, but that looks an awful lot like a GIF, so I'm going to treat it as a GIF and process it differently. But your web application firewall might not do that. So these types of tools can really help you to understand why or how you might attack something. At the core of it, when we take a look at how bypasses happen, the most reliable work on this really dates back almost 20 years now. It's a research paper called Insertion, Evasion, and Denial of Service, Eluding Network Intrusion Detection Systems. And it covers like old school IDS and really new school IDS, because most of the evasions still work, depending on how networks have been set up. It's a really great paper. If you haven't read it, it is an asset. If you want to learn how to think like an attacker and think about how to abuse systems, it's a fantastic resource. The bottom line is the network intrusion detection stuff all happens because any type of network application, it doesn't matter what type of infrastructure or service you're trying to operate, you have to handle a protocol. And because of that, you need a parser. And if you work in application security or security testing or application development, you all have a job because you are dealing with parsers. In my case, I really have enjoy the work that I do, but when I was working in Firefox, one of the biggest challenges that we often saw was, on Mozilla's web services when I was working there. We had a lot of different types of applications that would try to do different things, and leveraging weaknesses in the implementations of the protocols was the easiest way to target anything. The other thing to consider is when you're processing things as liberally as possible, the balance becomes that when you are implementing web application firewall rules, the strictness that you want to apply becomes the gate between having false positives and failing to protect the application that you're looking at. The challenge here is increased by the fact that HTTP as a protocol is a rapidly moving target. We're looking at changing how TLS works. TLS is going through an upgrade to 1.3, which is a significant shift. And one of the great things about it is that it has a really strict focus on reducing the number of options when you are setting up a TLS connection. The trade-off is that everybody and their dog is trying to get something shimmed in there so that they can continue to do things like TLS interception and fun stuff like that. HTML and CSS, as well as JavaScript, are incredibly complex. Trying to process those in a way that is reliable and meaningful in the context of an intercepting proxy or a forward proxy is very challenging, especially in the case of HTML and CSS. The standards are changing, new APIs and new functionality are being added all the time. And then on top of that, HTML5 and CSS3 have evolved to the point where they're both Turing-complete languages, or sorry, when they're combined, they are Turing-complete language. So there's no actual reliable way to say that this content is trustworthy. If you've ever written a JavaScript parser or anything to validate JavaScript, you may have heard of something called JSFuck, which is a way of re-encoding JavaScript so that it just looks like different delimiters and characters, control characters, rather than actual code. So with what all of this leads us to is understanding what a WAF bypass is, and the bottom line, it's essentially just malicious content that's not caught by the filters that you might write. It's essentially a string transform. So you want to take a string that exists and you want to modify it in a very small way. That can be in any component of the HTTP request. It can fit into the header. So commonplace headers that can be targeted are origin headers that tell you where the request is intended to go or where it's coming from. You can perform parameter mutation, injecting different characters, changing the encoding of characters and of components of the request, either the request line or individual components of the request body if your request method allows you to have one. You can also construct URIs that are not legitimate, but when they're processed through different encoding tricks within web application firewalls or application servers themselves, will be transformed into valid bypasses. So when you're targeting a web application, you want to figure out how it is that you're going to attempt to bypass the web application firewall. And there's currently about 3 different ways you can do it. The easiest way is manual testing. You can just, if you are aware that an application is vulnerable, but you don't necessarily know what web application firewall they're running, if they have one, you can simply attempt to try different variations on the request until things get through. You can run web scanners like Zap that have baked-in fuzzers and hope one of the fuzzer-generated test cases hits bypass on the firewall. Or you can do open source intelligence and comb through commit logs, pull requests, any kind of advisories that have been released by the vendors, and eventually construct the particular string that you need. Once you have figured out what kind of bypasses that you might have, you want to determine as much as you can about the firewall that's in place. You want to then take the attack that you want to perform and re-encode it as a bypass payload. Now, the fun thing is all of this stuff sounds super technically complex, but really you're just adding simple characters to a request. So I'll just hop over and do a quick demo here. So this is just a toy vulnerability that I crafted up. Where's my mouse? There it is. So this is just a typical login page. As soon as my window actually gets over there. Oh, no, hang on a second. Didn't practice this part of the demo. I guess nobody can see that at the back, so. This is a very common SQL injection vulnerability. All it is allows you to implement an SQL statement, an SQL query, and by formatting it, you can change who's able to log in. So normally you get an invalid login, but by escaping it, you can automatically bypass it. I'm not going to go into what SQL is or SQL injection is or why this is important. There's tons of documentation on that on the web. The vulnerability in itself isn't terribly important. What is important is that when I go into the application, hang on one second here, I just have to actually re-enable the firewall, the web application firewall on that. Yeah, it is. No, I just wanted to get back into the box before I move that screen over. So, I mean, actually turning on a web application firewall, once it's configured, is fairly straightforward. Nope, that's not going to work. That's the one. Now, if I've prayed to the demo gods correctly, then this should actually give me a forbidden. So now that the firewall is in place, you can see that it's just blocking it. This is just a really basic web application firewall setup. It's using the default settings for the OWASP CRS 2.2.9, which are out of date, but the intention of this talk wasn't to drop 0 day. That'll come probably at a future BSides event as we get a little bit more confident in the tool that I'm going to demo later. The goal here is to show that it's actually pretty easy to trigger an SQL injection vulnerability. And now I'm going to talk a little bit more about some of the things that we can do to make these vulnerabilities little bit more easy to do when you are doing an actual penetration test. So the normal process for identifying which web application firewall you're using is to use a tool like W3AF or WAF. Prior to the release of these tools in 2014, well, actually a little bit earlier than that, but most of these two tools weren't updated since then. The way to do it was to inspect headers, try different patterns and see what got kicked out, things like that. Now you can run these tools, and they'll tell you about a bunch of different commercial web application firewalls. Some of them will even enumerate modern cloud-based firewalls, but they're not very accurate. They don't have a large set of signatures that they can use to inspect. So you end up doing a lot of manual testing if it doesn't spit out a positive result right away. Then once you're doing some testing, there's the quality assurance route, which you can watch Christian's talk. It should be, I think Ron said yesterday's talks are already up on YouTube. Then you can also take a look at some of the older research. Yvan did a bunch when he was working on the IronB project. He has a bunch of different patterns you can use for testing and fingerprinting different ways you might try to bypass a firewall and determine whether or not they work. XSS filters are notoriously easy to locate. XSS bypasses are notoriously easy to locate just because the JavaScript developers keep giving us ingenious ways to do new things. And there's lots of enumerations of badness, basically laundry lists of different techniques that you can use. Like there's the old hackers.org website that lists a bunch of different bypass stuff. But ultimately, once you've identified the firewall that's in place and you've identified a potential payload, then you also need a way to do it. And the way that this is most frequently done is through manual exploitation. Exactly what you saw me do there. I went to the browser, I typed in a different string, and it triggered the SQL injection attack. Now, because I'm running a vulnerable version of a web application firewall, in particular, this web application firewall allows you to bypass it by inserting a comment. Come on. Remember when I said that if your web application firewall is missing a single character, that you can suddenly bypass everything? So I'm going to try this again. And so if I structure this as a proper query, there's a couple of different ways you can do things. That just gives me an error. This one will also end up giving me an error because that's not the kind of quote that the web application firewall wants to let through. But this one, if I happen to switch it to use a single tick and a hash, what did I do wrong there? There we go. So you just have to make sure that you've got the right piece of text injected into your WAF bypass attempt. So going back to the presentation. So there's a bunch of other tools that you can use. SQL Map has some of these WAF bypasses baked into it. W3AF, I believe Metasploit has some baked into it as well, but they're fairly limited, and they have a requirement that you're using the tool. There's also tools like XWAF and WAF Ninja that will take some of the well-known bypass strings for older WAFs and try to fuzz and find new bypasses in new implementations. But again, they are fairly limited in how you can end up using them. So when I started at Fastly, I guess it was about 6 or 8 months ago, one of the projects that Chris and our manager and I spoke about was the concept of building something like FragRoute for HTTP. And if you're not familiar with FragRoute, it's basically a network attack Swiss Army knife. It allows you to manipulate streams of traffic so that you can attempt some of the intrusion detection bypasses. You can insert weird traffic. It's not as flexible or capable as something like Scapy, but it's still pretty useful. So I set out to create a tool like this, but because I know how hard it can be to maintain these kinds of tools in the long term, I set myself a couple of different goals. I wanted to make something that would play nice with others. I spent a lot of time working with Simon Bennett from the Zap project at Mozilla, And one of the things that I learned is by chaining proxy servers together, you can combine all kinds of really cool tools. Lots of people like to use Zap and Peros, or not Zap and Peros, Zap and Burp Suite together, or other commercial scanners, and route them through other proxy servers. So I set out to implement my tool as a proxy server. I decided to make something that was easy to configure and was super portable. I'd written a bunch of different security tools in Python and got stuck in dependency hell, so I decided to go with Golang this time around. And then I wanted to build a tool that was really useful for both blue and red teams. So I wanted to make sure that this could be used for developers to be able to test and validate that their applications, or the web application firewalls they deployed worked effectively. But I also wanted red teams to be able to use this and add it as a tool to their arsenal to be able to prove that the blue team had done their job right. So enter Swizzle. It's a Golang project. It is not yet open source, but that is my own fault. I've got to coordinate with the legal team at my employer, and we're hoping to get it out this week. It's an intercepting or forwarding proxy. Right now it has a pile of different string transforms that you can apply, and then it packages up a bunch of those into evaders that you can apply to a connection. So it's portable to any Golang target, and it's configurable at invocation, but one of the features that I'm working on is also the ability to run it as an interactive proxy, so you can reconfigure it at runtime. So it's a command line tool. And I'm going to pray to the demo gods that this all works, and try this one out again. And once again, I'll just move my screen over in just a minute. So hopefully people in the back can see that. So this is just running this Swizzle in a proxy mode, and I'm selecting to use it in red team mode, which is basically using a sequence of transforms. And this transform is going to allow me to automatically bypass my WAF just by sending a more basic request through. So the other thing is that in order to use this, you have to have the application configured, or the browser that you're using configured to use it as a proxy. So I'm going to pull over a different browser. Oh, that's right. Different image. There we go. I should be more creative in my naming. So I'm going to try the exact same pattern that I did before, where so it still gives me a forbidden, but when I switch over to my console, I can see that in addition to all of the fun stuff that Firefox is trying to do in the background, before it scrolls off screen, you'll also see that at the top you have a request that's been passed through. The post to Foobot was intercepted, and it detected that the post body had a bunch of parameters in it. So it unpacked the parameters, and it attempted to translate them by converting the quotation mark or true into quotation mark or true. Now, in this case, we saw from the previous exercise that CRS 229 will block it with the double quote. But now that I know that it's actually picking up the parameters correctly, I should be able to just insert a single character to trigger the transform. And of course, I didn't pray to the demo gods loudly enough, so give me a second. No, I was actually switching to my editor for a second, because normally what I do when I'm doing demos is just copy and paste everything out of a text file, but I'm not doing that today because I'm a fool. So I'm just going to bring this over for a second because I'm not sure why it's bailing on me. I did this 5 minutes before my talk. All right, give me 1 second. I'm just going to change mirroring for a second. Okay, I'm going to come back to this in a moment and redo that demo. I'm just going to finish talking about the other piece about it, just because the talk's being recorded. Should have prayed louder to the demo gods. We'll come back to that. So the attack obviously didn't succeed in the time that I passed it through Swizzle. And we'll take a look and figure out exactly why in a moment. But the SQL injection attack is... The key part here is that the SQL injection attack is being rewritten. Now, I'm not sure why I'm tripping over. I may have enabled the wrong version of the firewall rules. If I enabled the 3.0 rules, this attack will be blocked, which would explain the forbidden. What's actually happening in the request, and each Swizzle rule applies its own transforms for each different type of possible WAF bypass. And currently, we have 12 bypass transforms implemented, as well as a total of 25 distinct evaders that will evade different WAF firewall rules, and a couple of custom ones that I've been rolling up for specific web application firewall rules. They can transform any request that passes through, but you can also configure Swizzle to target individual fields. So if you're using it in proxy mode, if you're familiar with an older tool called rat proxy, it'll just randomly try different security tests while you're browsing the web in the background. But Swizzle will do the same thing with web application firewall rules. When it's running in targeted mode, you can specify to only affect individual fields. So if you want to browse an application and then only have it try to do bypasses on specific fields that you know are injectable, you can set it up to do that. You can also specify it to target only specific routes on a web application. This is an example of what an Invader looks like. I don't know if you guys can see it in the back, but it's just a simple Golang script or function that handles all of the parameters for the request, applies the transform, and returns it. So you can embed these through, you can actually write these and ship them in the binary. We're also adding support. We recently ported it over to use Google Martian's proxy server. So along with that, we get the ability to embed some of these capabilities at runtime. We also have the ability to implement individual transforms. So this is a simple transform function that will iterate over a request, observe any MySQL white space, and try to inject different types of patterns that will trip up other web application firewall rules that are depending on seeing specific sequences of white space. It'll inject comments, different things like that. There's a couple of factors here. The way that these rules are applied are typically done randomly, but we extract in each of the transforms, we extract random settings that are global for the entire application, as well as the ability to configure each individual transform at runtime. And then we have evaders, which are typically just a simple wrapper like this, where it takes that transform that was on the previous slide and it packages it up and runs it across all of the parameters that have been configured. So you can run them across all of the keys in a request or response. You can run them, actually, as of this afternoon, you can run them in either a request string, request line or against a post body. And the recent upgrades to it mean that we have full HTTPS interception. We also have the discovery mode and targeted mode are both functional, except for whatever I did wrong there during my demo. We also have a feature called oracles. So as you're browsing and testing different applications with web application firewall rules, there's different characteristics of the response that might indicate that there's a WAF bypass in place, whether it's encoding errors, stuff like that. Hopefully in the next 2 weeks, I'll be releasing that feature. And it will help you to determine whether or not you found a WAF bypass and give you hints on how you might exploit it once you have. The next feature on the roadmap will be to absorb some of those YAML files that the FTW team has produced and be able to run those as fuzzers, as a corpus for a fuzzer against any WAF that's in line, and be able to try different evasions and transforms either in sequence, in building out a fuzzing plan, or just randomly applying them continuously. And then finally, something I'm going to talk about a little bit more on my next presentation on this. I started building a database of fingerprints for HTTP requests and responses, looking both at the different elements of the request and response headers and the request and response bodies to determine more information and build out an Nmap-style fingerprinting database that will help to identify both applications that are running behind and applications that are running in line that have different characteristics about how they make changes and respond to the different types of mutations that we're performing. As we try to evade a WAF, we should be able to figure out other characteristics and do more fingerprinting on what infrastructure is actually hosting the application. Once it's open source, which I will both tweet about and we'll be publishing some blog posts on the Fastly website about it. We'll be releasing it on GitHub at Swizzle Proxy. And if you're interested in contributing to this, we were supposed to have this out before I gave this talk, but patches will always be accepted. But if you are aware of any kind of WAF bypasses, we are happy to accept both information about a new technique, and if you have any links to research it or other resources for how to implement more bypasses, please do feel free to let us know. And finally, before I get to questions, I've got one for the BSides Winnipeg team. Why not in September, so that I don't have to worry about snowstorms? But
49 hours.
So with that, I will leave it to questions. But if you do have a question, please come up, because I am literally quite deaf. And I'm going to go back and see if I can figure out why my demo didn't work.